So in this session, let us continue with other display devices. Next one that we'll be seeing is cathode ray tube CRT. Basically, this was the technology used in earlier televisions and also some of the CROs, that is cathode ray oscilloscopes. So cathode ray tube, let us see what basically it has. On the left extreme end, it has pins for external connection for giving the supply, and here we have cathode, control grid, and then we have anode section, focusing anode section. We have three anode section here: pre-accelerating anode, focusing anode, accelerating anode, and then together it is electron gun. Together the anodes as well as the cathode is called as electron gun. Then we have deflection section, vertical deflection plates, horizontal deflection plates, and the dotted line here represents electron beam, and this represents screen. And the screen at this end, we can see the bright spot at the place where the green dot is displayed, and then this is phosphorus screen, and then the screen is shown here. Screen part snapshot is shown here. Phosphor, it is made of fluorescent material, and the deflection is also shown. So now let us see the parts of cathode ray tube and then the operation of the same. So coming to the electron gun, so this part is electron gun. As you can see here, it has cathode, control grid, and then next comes the anode part. So cathode, basically the heated cathode emits electrons. Then we have the control grid, which is connected to negative grid potential. As you can see here, it is connected to negative grid potential. Cathode, whenever heated, it emits electrons. Electrons are negatively charged, and even the control grid is also connected to negative grid potential. So we very well know that when both negatively charged particles are there, they repel from each other. So by varying the negative grid potential, we can control the momentum of electrons, the speed at which the electrons come out of that, and the intensity of the beam of electrons can be controlled by varying the potential of the control grid. So if the grid voltage will be increased, then the momentum of electrons will be more, otherwise it will be less. Then after this we have the anode section. So we have three anode section here: pre-accelerating anode, focusing anode, accelerating anode. See, pre-accelerating anode will be connected to plus 1500 volts potential, that is used to speed up the flow of electrons, because electrons are negatively charged. So the pre-accelerating anodes tend to pull the electrons, and accelerating anodes also does the same job. And in between we have the focusing anode. So a focusing anode is connected to plus 500 volts supply. As you can see here, it's connected to plus 500. The other two ends, pre-accelerating and accelerating anode, are connected to 1500 volts. So here this forms an equipotential surface with 1500 volts on either sides and plus 500 volts in between. Whenever a light beam enters the equipotential surface, it tends to deflect towards normal. Same thing happens to the electron beam. Electron beam entering the anode section from any direction always deflects towards the normal because of this equipotential surface. Then we have the deflection system. As you can see in the diagram here, this horizontal deflection and vertical deflection system forms the deflection system. So in horizontal deflection plates, we have two plates that are connected to Vy. In vertical deflection plates, they are connected to Vy on one side, the other one is connected to the ground. So Vy is basically when Vy becomes positive, electron being negatively charged tends to move upwards, and when Vy is negative, it tends to move away from the upper plate, and it moves towards the downward plate. So the vertical movement of the electron beam can be controlled by making Vy positive or negative. Similarly, when the beam enters the horizontal deflection plates, similar to what we have seen in vertical plate, when Vx is positive, the beam tends to move towards the right end of the plate, and when Vx is negative, it tends to move to the left end of the plate. Thereby, the horizontal movement of the beam is controlled by Vx. So, when simultaneously Vy and Vx are applied, the electron beam moves in vertical as well as horizontal direction simultaneously. So that is what is being described here, and you can see in this screen, in this figure, the vertical movement, and this shows the horizontal movement due to horizontal deflection plates. Then the last part is fluorescent screen. So the concept of persistence comes here. So persistence is nothing but time taken by the light to remain on screen after the signal becomes zero. So generally, we have heard about persistence of vision. Even after the object is absent, for few seconds, the eye retains that image. So that is called as persistence. Same thing happens over here. So the phosphor material basically is used on this screen, which is made up of zinc oxide, silicon dioxide, and then manganese, together called as zinc orthosilicate. This material, whenever they are bombarded by electron beam, emits green light. This phenomenon is called as phosphor burn, and the beam appears in green color because of this chemical combination that is used, zinc orthosilicate. So that is what will be displayed on this particular CRT. This is the overall operation of cathode ray tube display device. Next we'll see Nix tube. Please have a look at the figure here. Nix tube. This is another such display device. This contains a gas filled envelope, and this is called as cold cathode glow discharge tube. Here we can see the front view, and here we can see the side view. So in this particular case, this is basically a digital display device. It works on the principle of gaseous breakdown. That is, we very well know that at normal temperature and pressure, gases behave as insulators. When voltage is applied, the gas molecules will gain kinetic energy, collide with the neutral, and they get ionized. Ionization takes place. So whenever the ionization takes place, electrons are released. Therefore, the energy is released in the form of heat and light. So here neon gas is used at very low pressure, and any other gaseous combination can be used. Neon, when used, it will give orange red glow color. So the gauge electrode here acts as anode, while the wire shaped electrodes acts as cathode. So you can see here the gauge electrode, the outer surface is the gauge electrode, and then the wire shaped cathodes. You can see here different numbers, say 5, 8, 7, 1, and so on. They are acting as cathodes. So particular cathode, whenever is connected to the unit, a particular number is displayed. So it has 10 cathodes and 1 anode. To see them clearly, we have, go for the side view, we have 10 different wire shaped, number shaped wires, which are one behind the other in the side view. And then we have gauge electrode. In this, neon gas is filled. So whenever the potential is applied, the gas breaks down and the illumination takes place. So at when high positive potential is applied to the anode and negative potential is applied to the selected cathode, gas between anode and cathode breaks down and glows. Thereby, it shows the display. In the next session, we'll be seeing other display devices.